Japanese air-to-air missiles have stayed out of the spotlight due to Japan's non-offensive defense policy and export restrictions. This low profile has led to the belief that they would not be used in an actual conflict. However, given recent global developments, this assumption is no longer certain. As the weapon detective, we're now investigating the Japanese air-to-air missiles from the AAM-1 and AAM-5, the claws of raptors of the Japan Air Self-Defense Force, or JASDF. Japan's indigenous air-to-air missile development began in the mid-1950s, almost immediately after the rearmament permit was granted. Although the early examples were not very successful, the JASDF now operates domestically developed missiles, which are regarded among the best. Japan initiated a study on developing air-to-air missiles as early as 1956. However, shortly after, the JASDF began operating air-to-air missiles for the first time using AIM-9B Sidewinders mounted on its F-86 Sabres. Japanese engineers then began developing an infrared homing missile with performance matching the AIM-9B, marking the JASDF's first fully indigenous weapon of this type. Tokyo initially selected Fuji as the prime contractor, but the company withdrew in November 1961. Therefore, Mitsubishi, which would later develop all Japanese air-to-air missiles, took on the task. Prototype production began in 1962, and within a year, a successful ground launch test was conducted against a parachute-suspended target. In 1965, air launch tests were carried out from an F-86F. In 1969, Tokyo authorized the mass production and adoption of the missile known as the Type 69, also called the AAM-1. The AAM-1 cost 3.5 to 4.9 times as much as the AIM-9B and was inferior to the AIM-9E, which had just entered service in Japan. Subsequently, Japan ceased production in 1972, having delivered approximately 400 units. The JASDF, which deployed the AAM-1 on its F-104Js, F-86Fs, and F-1s, retired it in 1986. Japan selected the F-4 in 1968. At that time, because the US Air Force used the AIM-4D Falcon on its Phantom IIs, the JASDF also planned to equip its aircraft with this missile. However, 2 years later, Tokyo launched a program to develop a new air-to-air missile for the F-4Js. It would feature a superior all-around infrared homing mode, enabling attacks from the front and sides of enemy aircraft. Additionally, its electronics reliability would also be improved. A new high-performance rocket motor would enhance maneuverability and range, and it would be equipped with a more powerful warhead and a proximity fuse. Although the missile, called X-AAM-2, outperformed the AAM-4D, its high cost led Tokyo to cancel the project in 1975. Ultimately, Japan produced more than 2,000 AIM-9L and Ms under license. Again in 1974, Tokyo approved the development of a successor to the AIM-9L with improved detection, tracking, and maneuverability. The new missile was based on the Sidewinder to maintain compatibility with existing launch rails and avoid modifying current combat jets. Progress was slow due to ongoing AIM-9L and M license production. In 1978, Japan tested 3 models. It also evaluated radar and infrared TV sensors, but ultimately discontinued them during development. Detailed design began in 1981. The first prototype, X-AAM-3, was completed within 5 years. The initial air launch test took place in 1989. In 1990, Tokyo approved mass production and the adoption of the new missile designated as AAM-3 or Type 90. It reached full operational capability in 1991. The AAM-3 differs from the Sidewinder in that it lacks a stability roller on the tail fins. Its forward section includes a large notched canard to improve maneuverability and a stabilizer at the rear. the missile is controlled by a direct-drive electric servo actuator, which significantly improves response time and accuracy over traditional hot gas servo systems. It also employs bank-to-turn control, enhancing maneuverability by rolling to align its lift vector with the target, rather than relying on rudder or skid-to-turn methods. The AAM-3's dual-band infrared ultraviolet seeker is gas-cooled from a small tank behind the fins, allowing high scanning speed. This design greatly increases resistance to chaff flares. The all-aspect seeker's wide oscillation angle provides a larger detection field and excellent off-boreside performance. Furthermore, the AAM-3 features a directional warhead with a proximity fuse that uses an onboard laser to accurately determine the enemy aircraft's orientation and deliver a targeted attack. This approach is more effective than traditional proximity fuses, which only disperse fragments. These features make the AAM-3 significantly more effective than the AAM-9L. However, due to its ground-up design and comparatively lower production volume, it has also become twice as expensive as the Sidewinder. The JASDF has deployed the missile on F-15J and DJ, F-2, and F-4EJ Kai aircraft. Production ended in 2009 in favor of the AAM-5. The dual-band infrared ultraviolet homing AAM-3 measures 3.1 meters in length, 0.64 meters in wingspan, and 127 millimeters in diameter. The missile weighs 91 kilograms and carries a 15-kilogram high-explosive fragmentation warhead. Its maximum effective range is 13 kilometers. The top speed of the AAM-3, equipped with a solid-fuel rocket engine, exceeds Mach 2.5. Japan began technical research on a domestic beyond visual range missile around 1985. In the 1990s, however, the country considered replacing the US-made AAM-7 Sparrow missiles with the still developing AAM-120. Since the USA prioritized NATO allies for its top weapons, concerns arose about the missile's reliable supply, cost, and delivery time. As a result, in 1994, Tokyo authorized the full-scale development of a weapon with capabilities equal or greater than the AMRAAM. Ordered in 1999 after the development phase, the new missile, AAM-4, also known as Type 99, achieved initial operational capability only in 2007. It uses inertial guidance and command guidance from the launch aircraft via data link for the initial to mid-course. This method requires the dedicated JARG-1 command and control system, as the modulation scheme prevents the aircraft's fire control radar from being used. Its inertial guidance relies on a compact, highly responsive fiber optic gyro for improved performance. Before terminal guidance, the missile activates its H-I-band radar. This design enables both fire and forget and guided after launch modes. Consequently, JASDF interceptors can simultaneously engage multiple targets at extended range. Enemy aircraft's radar warning receivers can detect the attack only when the missile's radar, with a 15-kilometer detection range against a 2.5 square meter target, locks on. The radar uses a compact, powerful gallium arsenide semiconductor transistor, which is more cost-effective than a traveling wave tube. It improves lock-on, electronic countermeasures, and anti-clutter functions, and enables targeting of moving objects. The missile can maneuver at up to 20 G. The AAM-4 uses a fuzzy guidance logic control system that considers over 70 values in its calculations, rather than a PID or binary logic controller. It also features better energy retention than others. The Type 99 with a directional warhead is also highly effective against anti-ship and land attack cruise missiles as required by the JASDF. Some sources claim Japan acquired the AIM-120 because the AIM-4 cannot be carried or launched from the F-35's weapon bay due to its size. However, Lockheed Martin stated that if the lengths are similar, a 1-inch difference in thickness is manageable and changing the attachment would resolve any issues. The actual reason Japan acquired the AIM-120 for its Lightning IIs is the requirement to install the JARG-1 on the aircraft. Furthermore, modifications, even minor ones, and software updates to integrate Type 99 would add costs. Consequently, the JASDF deploys the AIM-4 on only F-15J and F-2 variants equipped with the JARG-1. The active radar homing AIM-4 measures 3.67 meters in length, 0.77 meters in wingspan, and 203 millimeters in diameter. The missile weighs 222 kilograms and carries a 31.3 kilogram high-explosive fragmentation warhead. Its maximum effective range is 85 kilometers. The top speed of the AIM-4, equipped with a solid fuel rocket engine, exceeds Mach 4.5. The AIM-4B variant, also known as the Type 99 Chi, has a range of 105 kilometers and maneuverability of up to 25 G and enhanced electronic countermeasures. It offers improved performance against cruise missiles while reducing its cost. The AIM-4B is the first missile to use an active electronic scant array seeker. Alongside new signal processing capabilities, this K-band seeker provides the B variant with a 1.2 times the standoff range and 1.4 times the autonomous guidance range of the original AIM-4. Between 2000 and 2007, Japan also worked on an AIM-4 version combining a solid fuel rocket and a ramjet, aiming to extend the range to 170 kilometers. This program was discontinued after 2007 as Japan shifted to a joint research project with the UK to develop an improved Meteor version equipped with the AIM-4B seeker. The XR-IM-4 is a surface-to-air variant intended for shipboard deployment, which is under development. Japan began developing a replacement for the AIM-3 just 1 year after it entered JASDF service in 1990. Tokyo authorized the mass production and adoption of the new missile called the AAM-5 in 2004. Also known as Type 04, it became fully operational in 2008. The missile's fiber-optic gyroscope-based inertial navigation system, when combined with a helmet-mounted sight, enables lock-on after launch. With thrust vector control, free-moving control surfaces, and 4 additional tail fins, the missile can perform high-G maneuvers. The AAM-5's locking distance is 6 times greater than the AAM-3. Its infrared imaging seeker, mounted on a 3-axis gimbal, significantly expands its field of view and provides strong resistance to chop flares. The AAM-5 features a directional warhead with a laser proximity fuse. The JASDF deploys the missile on the modernized F-15Js and F-2s while using the AIM-9X on the F-35. The infrared imaging homing AIM-5 measures 3.11 meters in length, 0.44 meters in wingspan, and 130 millimeters in diameter. The missile weighs 95 kilograms. Its maximum effective range is 35 kilometers. The top speed of the AIM-5, equipped with a solid fuel rocket engine, exceeds Mach 3. The AAM-5B variant, also known as the Type 04 Chi, offers enhanced resistance to infrared countermeasures. Its Stirling cycle cryogenic engine cools the seeker for up to 1 hour using only electrical power, eliminating the need for compressed gas reservoirs. This design improves operational effectiveness during extended patrols. Japan has acquired AIM-9X and AIM-120 missiles, despite its ability to develop effective domestic alternatives. Constitutional export restrictions are the primary reason for this situation. Low production volumes also make it economically impractical to implement necessary modifications and software updates. This situation may change under the new Japanese Prime Minister, potentially affecting the outcome of this endeavor. In a total war, having another major producer with high-quality products among the allies is a significant advantage. As the USA pursues new, long-term adventures with uncertain results, Japan can help reduce potential supply chain disruptions. Thanks for watching our video. And please don't forget to subscribe to our channel and click the bell button to be notified of our new videos. For more contents like this, please consider clicking the join button to support our channel. And as always, we would greatly appreciate all of your likes, comments, and shares.